Yeah, well, okay. So we forgot to turn on the recording. So these problems finding the inverse of a log function will be on the test. We did a simple one here. I walked everybody through it. And then I gave this to everybody to work on. And then we did it, and I still forgot to turn on the recording. So there it is. Okay. So I need to erase this, go on to another problem. I'm not even close to Hamida's problem yet, but we'll get there eventually. Is finding the inverse of a log okay with everybody? It's going to be on the test. Okay. I don't hear anybody yelling and screaming. Then the other thing that people kind of missed on the quizzy was finding the inverse of an exponential. Okay, so suppose you had f of x equals, I don't know, 5 to the x minus 3. So here's an exponential function, and I want you to find f inverse of x. Okay, a little bit different. Okay, first we're going to do this as y equals 5 to the x minus 3. Swap the x's and the y's. X equals 5 to the y minus 3. Notice the minus 3 is not in the exponential position. It is not. Okay. Add 3 to both sides, like we did before. Okay, this is where you guys got to put your thinking caps on. In order to get the y out of the exponential position, okay, we're probably going to ln both sides. Now, we could do it differently, and I'm going to walk you guys through that. But you're going to ln both sides. Or maybe Bra-Bar, I don't know. But you have to get this alone before you ln both sides, before you apply the Bra-Bar rule, before you do anything. So you have to get the x minus 3, or x plus 3 rather, isolated. Now, at this step, there's about 5 dozen ways you can do this problem and get the correct answer. And all 5 dozen ways will look really different, but they'll all be mathematically correct. I will take full credit for if you use any of these. Okay, so the way we've been working through this, I'm going to do 2 of them. We've been taking the ln of both sides equals the ln of 5 to the y. That allows me to bring the y down. So the ln of x plus 3 equals y times the ln of 5. Divide both sides by the ln of 5. So the ln of x plus 3 divided by the ln of 5 equals y, but instead of y, we'll say f inverse of x. And we're done. Now that's one method. Okay, that's a perfectly legitimate way of doing this problem. Okay. At this point right here, we have x plus 3 equals 5 to the y power. About a week and a half ago, I showed you this other technique. Nobody, I said, okay, I lied. I got to wait a minute. What I said when we introduced taking the ln of both sides is this is generally the most used method for solving these. Generally, it's the most used method. That doesn't mean it's the best method. And what I said was some people would take the log base 5 of both sides. Okay? Because they're looking into the future. So this is the log base 5 of x plus 3 equals, bring down the y, times the log base 5 of 5. Where's my glare? I'm right in the middle of it. Do you guys understand? This is the same step as this. I'm attacking this problem in a different way. So instead of taking the ln of both sides, I'm taking the log base 5 of both sides. Okay, because I know that eventually I'm going to get the log base 5 of 5, and that is going to become 1 by one of our log laws. So that gives me the problem. This becomes the log base 5. Am I in the glare? No. Of x plus 3 equals, again, in place of y, we put f inverse of x. Okay. Alternate way of doing it. Both ways are perfectly correct. Perfectly correct. I want to show you a third way. And then I'm going to say, I don't care which one of these methods you use. Okay, just get it right on the test, because I would accept any of these answers that I'm going to show you. So from here, we have x plus 3 equals 5 to the y power. So starting at that same place, notice all of these methods, you had to get the exponential part alone, isolated, before you did any of this fancy stuff. All right, I'm going to apply the bar rule right here. Okay, going from an exponential to backwards to a logarithm. Okay, again, Jan would probably doesn't like this because everything is in the backwards order. It doesn't matter, but remember, the base of the exponent is the base of the logarithm. When you're going from the bar rule, the base of the exponent becomes the base of the logarithm. Okay, and of this x plus 3, and it always equals the exponent, y, which is the exponent. So the logarithm always equals what was going to be the exponent. And the base is the base. The base of the exponential becomes the base of the logarithm. So notice this answer and this answer are the same thing, but it took me about a third of the steps, even half of the steps. Okay, so basically, I don't care what method you use. Doesn't matter, because this and this, well, obviously, and that are all the same mathematically. Any questions about anything I've done up there before I turn you guys loose on one? Okay, remember, the game is before you do all this fancy stuff, before you do the bar, before you take the log or the ln of both sides, you have to isolate the weird stuff. You have to isolate the 5 to the y. So what I want you guys to do here is g of x equals 2 times 6 to the x power plus 18. I want you to find g inverse of x. Make it minus 18. I'm sorry, make it a minus 18. 2 times 6 to the x power minus 18, and I want you to find g inverse of x. So we write this as y equals 2 times 6 to the x minus 18. Swap x's and y's. X equals 2 times 6 to the y, quantity minus 18. Now, before we apply log base whatever, we want to get this 6 to the y isolated. We want to get that quantity all by its lonesome. So we're going to add 18 to both sides. Okay, quantity. equals 2 times 6 to the y. We want to divide both sides by 2 or multiply by a half. It might be cleaner to say multiply by a half. You'll, whatever, 1/2 x plus 9 equals 6 to the y power. I chose to multiply each side by a half and distribute it in. It's just a little bit cleaner.
If we did divide both sides by 2, would it still be acceptable?
Yeah, it'll be messy looking, but yes. Yes.
My answer was log base 6 times x plus
Not
8.
times, of
Sorry.
Of x plus 18 all over 2.
Yes.
Yes, that's fine. Okay.
Wait,
So-
sorry, Professor. Sorry.
I'm sorry.
What's the half for again?
Well, you wanted to get rid of the 2. Do you want me to do what Mitch said?
Dang, I think I just divided it by. Okay, got
That's
it.
fine. That's what Mitch was saying. Let's look at it. Okay. So whatever, you got to get rid of the 2. Okay, that gives you x plus 18 all divided by 2 equals 6 to the y. Where's my, okay, I'm right on top of it. Okay, now this is where we have some leeway. If we take the log base 6 of x plus 18 over 2, it'll equal log base 6 of 6 to the y power. So we're taking log base 6 of both sides. That will give me log base 6 of x plus 18. I'll move out of the way in a minute, over 2 equals, that'll become y, because when you move the y, you'll have log base 6 of 6, and that's just 1. Is that okay? I just skipped a step because I'm lazy and I'm running out of room on the board, but I'll show you that step if I need to.
Okay, I see that.
You do? Okay, good. All right. So then the only thing you have to write here is this is G inverse and you're done. Okay. If you did it another way, you'd have the ln of x plus 18 over 2 over the ln of 6. If you use the ln of both sides. A little bit messy, a little bit ugly there, but that's
Can
it.
we write ln minus ln of 2? ln x plus 18?
Yeah, minus ln of 2 all divided by ln of 6. Yeah,
Yes.
yeah, because you're using a log law. Sure. I can guarantee you that'll screw up mom. It won't screw up me. I'll look at you and go, what the? Oh yeah, I remember now. Okay, I'll figure that one out because I'm going to hand grade your test on Thursday. Mom won't have anything to do with it. Is that okay with everybody?
Professor, did you finish the x plus 18 over 2 equals 6y? The way you were showing us for Mitch's
Yeah,
solution?
I did, but I skipped a step. Okay. So let me come back. So right here, okay, I took the log base 6 of both sides. Okay, so that gives me log base 6 of x plus 18 over 2 equals y times log base 6 of 6. Because you're allowed to bring the power down once it's a logarithm. And then this log base 6 of 6 is 1. So this is log base 6 of x plus 18 over 2 equals y, but in place of y, we write G inverse, and we're done. Okay or not okay for everybody?
Yeah, thank you.
Okay. All right. So there's going to be two questions. Well, one question is going to find the inverse of an exponential like this. And then I originally erased find the inverse of a logarithm. I guarantee those will be two questions on the exam on Thursday. That's a guarantee. All right. I want to do Vince's question and then get back to Hamida and then open it up to a few other questions before we get into new stuff tonight. And okay, we're so wrapped up in chapter 10, I don't want you guys to forget chapter 9. Okay, chapter 9, we had to solve all kinds of quadratic equations. Don't forget that. There's the quadratic formula. Okay, there was factoring. There was the square root property, and there was these kind of things, 2x to the 2/3 minus x to the 1/3. I don't know if this even has an answer. Minus 7 equals 0. That probably doesn't have an answer. But those kind of equations are going to be on it. Those are all from chapter 9. So don't forget that. Okay. There's going to be a right triangle Pythagoras. Okay. Now these are all on that handout I gave you, but you guys don't read that too much. You might want to read the handout about, topics that are on the exam number 3. Okay. There's going to be some complex arithmetic. Things like, what's 5 minus 2i quantity squared? Remember, I is that weird number. Or what if you had 2i over 7 plus 5i? How do you rationalize it? Go back and look at your homework and your notes for that. Chapter 9, we did that. That was called complex numbers or complex arithmetic. There's some questions that are going to be on there. Okay, some solving. And lastly, there's going to be inequalities. That require interval testing, which I've gone over until I'm sick of it. I don't know about you guys. Okay. So if you had something like x squared minus x minus 6 is greater than or equal to 0, remember we would solve it as if it were an equal sign. Okay, as if it were an equal sign, and we get critical values, put them on a number line like I've shown about a gazillion times. Okay, and then test with the words true and false and all kinds of stuff. So that's all chapter 9, and that's part of the exam also, not just chapter 10. Chapter 9 is all of this junk and chapter 10. So you guys got a lot of things to be studying between now and Thursday. But, okay.
Professor, is this exam harder than chapter 11?
Yes, this is the hardest exam. Chapter 11 is all new stuff. Okay, but it's all new, but it's relatively easy stuff. This is hard. This is nitpicky. This is, just nitpicky. Terrible. Yeah, like I've been writing in all my emails, this is the hardest one of the entire semester.
So there's light at the end of the tunnel.
Kind of, and then the train hits you, remember that light at the end of the tunnel is a train coming. That's a bad joke. Okay. Vince asked this question. Okay. It said, it was something like, you have $5,000 now. This was on the quiz. And eventually you want it to turn into $7,100. at 4.5%. Now, this was the problem, compounded. Now, Vince's question, you said it was weekly. The one I looked at, the same problem was monthly. Okay, it doesn't matter. So how long does it take? Long, L-O-N-G. How long until you get $7,100? This is one of the questions on the quiz. Okay, and for every person, you got a slightly different one. Vince apparently got compounded weekly. The one when I happened to look at it, it said compounded monthly. The concept is the same. It doesn't matter. So, and I gave you this formula. I said A of t equals A sub 0 times 1 plus r over n raised to the n times t power. Now, when I taught this to you weeks ago, okay, instead of A of t, Mom wrote this as future value. What is the value in the future? But it's the same as A of t, so it doesn't matter. All right, so I'm sorry. Okay, so we have 7100 equals 5,000. That's what it said. We start at 5,000. We want to end up at 7,100. Okay, start at 5,000. That was the initial, end up at 7,100. 1 plus the rate was 0.045. Remember, you had to change always the decimal. They give it to you as a percent, but you have to use it as a decimal. Okay, now this time, because it says compounded monthly, we use 12. N is 12. When it was weekly, well, it should have been 52. Oh, quarterly. Yours was quarterly. That's right. I'm sorry, Vince. So N was 4 quarters in a year, raised to the 12 times T. So that's the formula. Notice we're solving for time because in this mess, time is the only variable. And that's in this case what it is. How long until we have, or how many years until we have $7,100? Now, I don't know exactly which problem this is for everybody because the problems all got randomized. But this was one that enough people got it wrong that I was a little bit worried. Enough people got it right also, but some people got it wrong, so I wanted to go over this. So we're going to do two things simultaneously. The first thing I'm going to do is divide both sides by 5,000. Okay. And simultaneously, I'm going to calculate this mess, whatever this 0.045 divided by 12 plus 1. So let's see what I get. So this became 1.42 equals, okay, this is going to be 0.45. 1.00375 raised to the 12t. And this becomes like a whole lot of problems that you guys were asking me earlier tonight. Once we've worked through this, then the question becomes, how do I get the 12t out of the exponent position? How do I get it out of there? There's a couple ways. Easiest way is to ln both sides. That allows me to bring the 12t down.
Could we also use the bar-bra rule on this?
Oh, yeah, cool. Yes, you could. Hang on, let me finish this one off, but I'm glad you said that. 12t times the ln of whatever this crap is, 1.00375. Okay, so we have the ln of 1.42. I'm glad you said that. Personally, that's what I would have done. Okay, that's what I would have done. But once I started showing you guys the ln both sides, I want to kind of stick with it. Just so I hopefully don't confuse you too much. Divided by this mess, the ln of 1.00375 equals 12t. So this is a job for my calculator now. So I'm going to calculate these two numbers, division, then divide it by 12 to get t alone. Let's see what I get. So ln 1.42 divided by ln 1.00375, close. Got some ugly number. Then I divide it by 12. So I get 7.8069 equals t. Remember time. Okay, t is time. Again, I don't remember what mom said to round to, 3 places, 2 places. But what this basically says in 7.8 years, okay, your $5,000 will grow to $7,100 at this interest rate. If you could find that interest rate anywhere, put every dime you have in it. Lock that interest rate in. Nobody has that anymore. Okay. So I was concerned. I don't know why people missed it. I don't know if they didn't even understand the problem. I don't know if they screwed up on the math inside of the problem. I don't know. Before I do the bra-bar thing, who mentioned that?
Lindsay,
Lindsay, okay, thank you. Okay, before I show you that, is my work okay with everybody? Any questions on that? Okay, I don't know if I should give you a hint. All right, nah, I won't. All right, so Lindsay made a really cool comment right here. Right here, boom. Remember, you've got to get this quantity to the power isolated, and now you can take the ln of both sides. But Lindsay suggested, wait, why can't we use the bra-bar rule? We did it on the previous problem. Remember, if you have 5 equals 3 to the x power, okay, you can apply the bra-bar rule. This becomes log base 3. Okay, the base of the exponent and the base of the log are the same, of 5 equals x. Okay, that's just using the bra-bar rule. It avoids having to take the ln of both sides. You're going to get the same answer, okay, but it's a little bit quicker. So if you have this simple exponential, you can apply the bra-bar rule and turn it into a logarithmic. Well, it's kind of messy what Lindsay suggested, but if we look right here and apply the bra-bar rule, okay, that's going to be the log base 1.00375 of 1.42 equals 12t. The base of the exponent and the base of the logarithm are the same thing. Okay. If you have the magic button on your calculator, which is log base of that, some of you have that button on your calculator. If you got the 36X Pro, cool, it'll do that right away. If not, if you don't have the magic button, then this becomes log of 1.42 all divided by log of 1.00375. This is called the change of base formula because it allows us to change it away from base 1 point whatever into base tens. Okay, base 10, base 10. And it still equals 12t. So you calculate this mess out, and then divide by 12, you still get the same answer wherever I got it. So yeah, Lindsay, if you've really got that Bra-Bar rule in your brain, man, you can use it to save all kinds of steps.
Oh, it
Okay.
is not in my brain, but I need the practice. So I'm
Okay.
when I can.
Okay. Yeah, well, not everybody likes the Bra-Bar rule. I see it's useful everywhere. It's like when I do equation solving, a lot of times I see proportions and you guys don't see them that way. But by my seeing it as a proportion, it makes my work easier. Same thing here. If you can see a use of the Bra-Bar rule, okay, then it makes your work infinitely easier. Well, infinite is kind of a big word. So anyway, Vince asked this one before class, and I did it for him, only he was compounded quarterly, so that meant n was 4, because there's 4 quarters in a year, okay? Whereas we did it monthly, and it was 12. Questions. This was a missed problem on the quiz. I don't know why you guys missed it. Again, was it just you screwed up? Okay, you put the wrong numbers in, or you made an algebra mistake. I don't know, but are you okay with it now? Okay, I hear no sign. Questions? We okay? All right. Then finally, Hamida, you're here. What was your question?
Hello. Okay. I will read it. I'll read it
Wait.
to you.
I'm sorry, I didn't mean to wake you up.
I'm here.
I
Okay.
know. I'm okay.
Okay. It's just another bacteria problem. I don't know. If everyone's sick of it, I can definitely wait until after class.
Now let's do one more, and then I'm going to go to new stuff anyway.
Okay.
So this will be the last of the old stuff. I'll get us into new stuff, and that'll be it. All right, go ahead,
Okay.
read it.
A culture of bacteria grows according to the continuous growth model. B equals F of T equals 400 E to the 0.
Oh. A of T, wait a minute.
Sorry.
Read again.
The equation says B equals F of T equals 400 E to the 0.069 times T. And the question is, there are 3 questions. Where B is the number of bacteria and T is in hours. Okay, first one is find F of 0.
Okay, so here, this B here is stupid. Okay, that's how our functions are. The number of bacteria at a certain time is given by this formula. That's all that says. How many bacteria we have at a certain time is given by this formula. So the question was at time equals 0. So that would be F of 0 equals 400 times E to the 0.069 times 0. Okay, but this will be 400 times E to the 0, which is 400 times 1, which is 400. So at time equals 0, initially, okay, there were 400 bacteria. Is that okay?
Yes.
All right, second half.
I'm just writing what you wrote down. Okay.
right.
To the nearest whole number, find the number of bacteria after 4 hours.
What was time in terms of originally? Was it hours or minutes?
T is in hours.
Okay, fine. So f of 4 is t equals 4 hours, whatever. So we go 400 times e to the 0.069 times 4. And so that's just grunt work on your calculator. Okay. How many steps do you want me to show you?
I can, well,
Okay, tell you what, turn this on. Okay, I'm going to do e to the mess and see if you get that.
okay.
Okay, so e to the 0.069 times 4 e to the. So I get This should-
1.31.
1.31, whatever. Don't,
How far do I have to write out?
huh?
Doesn't matter. Okay, never mind. Keep going.
Okay, times 400. Okay, so I get 527 point whatever 139. So 527 bacteria after 4 hours. Yes or no?
Yes, and then the third one is to the nearest tenth of an hour, determine how long it will take for the population to grow to 700 bacteria.
All right, so, okay. 700 equals 400 e to the 0.069 t. That's your equation that we want. Again, initial was 400. It's going to grow to 700. What our job is to solve for time. Okay, so that's the equation. Is that okay with you?
Yes.
All right. I'm going to divide both sides by 400. And I believe that's 1.75. Is that right? I'm doing that in my head. I better not.
That's correct.
Is it really? I made enough mistakes. Yay. Okay. So we ln both sides. The ln, or do you want me to ln both sides, or do you want me to use the blah rule? Nah, let's ln. Forget it. It's actually better on this one to ln because it's got an e in there. Okay. So the ln of 1.75 equals 0.069 t times the ln of e. So, okay, the rest of this I'm just going to do on my calculator. Again, the ln of e is worth 1, so it essentially drops out of the problem. So if I want to get t alone, I'm going to divide both sides by 0.069. So here I go. ln 1.75 divided by 0.069. And I get 8.1103, 7 whatever equals t, and it said round to the nearest tenth. So 8.1 hours.
Okay, thank you so much.
Okay. Is that okay
looks
with
so much-
everybody? I'm sorry,
It
go ahead.
looks so much easier when you do it. You're
I
like,
know.
oh yeah, you just do this and this. And then when I see it, I'm like, okay, thank you.
Okay, but that's part of why we're going over this and over this and over this. Which is, I mean, now I'm going to get political, which is why I think their plan for us moving on campus in the fall is stupid. Okay, either we should be there every day or no days, but whatever. I really would appreciate you guys' input. If anybody has an opinion, email it to me about 4 days or 3 days, or whether you want to test on a Monday or test on a Thursday if it's 4 days. Just any opinion you have, I would appreciate. I have a meeting tomorrow with one of the department chairs, and I'm trying to get clarification. There's a lot of things being said that don't make sense to me at all. So I have a meeting tomorrow at 3:30, a Zoom meeting, yay, with a department chair, and he and I are going to try to work things out, or a little bit. He's actually going to tell me what to do, and I'm going to say, yes, sir, whatever you say. All right. So tomorrow night, tonight, I am going to start new stuff. Tomorrow night, I'm going to also continue with new stuff, but I will answer as many questions, almost as many questions as you guys can ask. Okay, remember, it's chapters 9 and 10. I know we're all wrapped up into 10, but you can't afford to forget 9 and all that stuff I wrote on the board. Go back into Canvas. Okay, I put a topics list, a breakdown of the topics that are going to be there and how many kinds of each problem is going to be there. So go back into Canvas in exam 3 module and see if you can figure out, okay, maybe some questions. All right. We're going to get into chapter 11. All right, here we go. Chapter 11.1. The title for chapter 11 is called Conics. Okay. I'll try to explain a little bit later why it's called that. But basically, the root word is called cone. Okay. So if you can think of, ooh, that's cool. This is May the 4th. I could talk about lightsabers. Nifty. What if you took an upside down ice cream cone? Well, that's stupid. Okay, now you can see that I can't draw. What if you took a cone, okay, of some form and took your lightsaber and sliced it at different angles? Okay, what if you took your lightsaber? Don't worry about this, guys. This is not going to be questioned. This is kind of just motivating you to kind of go, why in the heck is it called conics? If you took your lightsaber and slashed it this way, and then took it apart and looked at those two parts, okay, what shape would they be? Okay, what if you took your lightsaber and slashed it at an angle and looked at those two parts, looked at them, took it apart and looked at them, what shape would they be? And how does the angle change the shape and the size of the shape and everything? Now, if you go back online somewhere and just type in conics or conic shapes, you might find eventually a cone, something where people take it apart and show you the slices. It's not critical to me right now for us, but that's where it comes from. Taking a cone and slicing it with your lightsaber. Okay, we're going to learn 3 formulas tonight. Okay, the first formula is called the midpoint formula. Okay, suppose, let's look at this. Suppose you had this point A, which is, I don't know, let's say 3, 1, and we want to come up here to point B, which is, I don't know, 9, 11, and you have a segment like that. And I want to know what's in the middle. and they almost always use a capital M for what's in the middle of this sucker. Okay, what are the coordinates, the ordered pairs? Well, I'll show you. Okay, and then have you guys work one out, and then we'll be done with it. It's that easy. So what we're going to do to find the coordinates at the midpoint, and which I write as x sub m, that means x at the midpoint is 3 plus 9 divided by 2, which is 12 divided by 2, which is 6. Okay, the x value at the midpoint is 3 plus 9 divided by 2. What did I just do? What math action did I just do? 3 plus 9 divided by 2. What's that called? Nobody knows? Well, let's think about it this way. Y at the midpoint. Oh, well, this was kind of stupid. 1 plus 11 divided by 2 also is 6. So the midpoint right up here is 6 comma 6. Unfortunately, I didn't mean to do it that way, but it came out. So what's it called when you add up two numbers and divide by 2?
Arithmetic.
Yeah, but what are you doing? It is,
The
huh?
median?
The
Okay.
y-intercept?
Middle?
No, you're thinking too hard. How about just the average? Median was a better, it's called actually the mean. The mean is add them up, divide by how many? When you're adding up two numbers and divide by 2, you're finding the average.
That was the word I was looking for.
Oh, sure it was. Okay. Yeah, if you say
It
so,
was,
I'll
I
believe you.
swear.
Okay. All right. That's it. That's all the midpoint is the average. The average of the x's and the average of the y's, but you stick it as an ordered pair. Now, to confuse you, okay, when you go read a book, they're going to do this. If you go read a math text and you look for the midpoint, or go Google the midpoint of a segment, okay, you're going to find a formula that looks pretty much like that. And with all these sub onesies and sub twosies and fractions, you guys all panic. But wait a minute, what's that say? Add the two x's, divide by 2. That's all it says. Comma, add the two y values, divide by 2. It's saying find the average. That's all it's saying. So the midpoint is the average of the x's. Okay? So here's a segment. Okay. A has the coordinate -5 radical 2 comma 7. Okay. B has the coordinate 8 radical 2 comma -13. 8 radical 2, that. Find the midpoint wherever it is. So x at the midpoint is -5 rad 2 plus 8 rad 2 divided by 2. Okay, which makes it 3 radical 2 divided by 2, whatever that is. Okay, add them up. -5 radical 2 plus 8 radical 2. We talked about that a couple chapters ago. There's that. Y at the midpoint, y sub m, is 7 plus a -13 divided by 2. Well, that's -6 divided by 2. That's -3. So the midpoint, wherever that is 3 radical 2 over 2, comma, -3. So that mess right there, whew, miss the glare, is the midpoint. That's all
You
there is
want-
to it.
Would
Go
you
ahead.
want an actual answer for 3 square root 2?
No, because if I gave it to you as radicals, just leave it as radicals.
Gotcha.
Okay. Now they might give it to you and mom as decimals, so you do it as decimals, whatever. But that's it. That's called the midpoint. Pretty simple. Okay. That's it. I'm done with midpoints. You can work on mom on that. Next topic. Next topic is called the distance. Well, actually, maybe before I erase, anybody have any questions? Now that
I
I-
was writing down the formula at the top.
Okay.
It was x1 plus
X of 1 plus X of 2 all divided by 2, and it was M equals.
Oh, 2, okay.
Yeah, because you're finding the average of two numbers. Add them up, divide by 2.
So the craziest midpoints we get is just like pretty much everything else, everything we saw before, like radicals or
Yeah.
stuff like that.
Yeah, but it's basically add the two numbers up by whatever rules we had and divide by 2. That's it. Yeah, so if they're radicals, if they're imaginaries, if they're, whatever, add them up, divide by 2. To be really honest, when I test this, I might give a radical. I'll probably give whole numbers, and that'll be the end of it, just like these two examples. Okay, you need to know it, but I don't feel like wasting my time. There's enough other stuff we need to know. So what about the distance? How far is it? If you were an ant and you had to walk from A to B, what's the distance? Well, I'm going to show you 2 ways of doing it. And in the end, both ways have to give you the same answer. One way is more mathematically efficient. Okay. But most people don't like it, most in higher level classes. But I want to show it to you anyway. So here's the one way. If I want to go from A to B, why don't I make a right triangle? Okay. And instead of thinking this is a line segment, why did I think of this as the hypotenuse? So, question, on the horizontal line here, on the horizontal line, how long is this horizontal line? From 3,1 to 9,1, just the horizontal line.
6.
So how'd you get that?
9 minus 3.
Thank you. 9 minus 3 is 6. Yes. So the horizontal line is 6. What about the vertical line? How long is the vertical line?
Ten?
6.
Ten.
Isn't it? It's
10.
How much? 10, isn't it? Somebody say 10, please. I heard somebody say 10.
Yeah.
Okay. Yeah, okay. So how'd you get it? It was 11 take away 1 is 10, right? That's what you guys did?
Yes.
Yes.
All right, thank you. All right. So how can we use this to find the hypotenuse? Well, we say the hypotenuse, h squared equals leg squared plus leg squared. Remember Pythagoras? So hypotenuse squared equals 10 squared plus 6, squared, whatever this is. So this is 136. So we square root both sides. H is, your calculators, somebody tell me what the square root of 136 is. I know 4 goes 2 radical 23. 22? Anybody?
2 radical 34.
34, really? Crap. Okay, I was way off. Okay, good enough. So that's the distance. And then if you push the FD, it'll tell you, yeah, it's kind of like 12 or something like that, 11 point something, I don't know, 12.
11.66.
Okay, 11.66. So H is approximately, where's my glare? 11.66. Okay, now, so that's one way to find the distance, is simply turn this into a right triangle problem. The alternate way is to memorize what's called the distance formula. The distance formula. And it looks like this. Now, don't panic. Yeah, you will. Okay. D equals the distance equals big old mother square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so let's apply the distance formula to this sucker and see what happens. And then I'll show you where the distance formula came from. So we have d equals the big giant square root. The second x, okay, 9 minus the first x, 3, quantity squared. Check it out, 9 minus 3, plus the second y, 11, minus first y, 1, quantity squared. Check it out, 11 minus 1. So this distance formula, d equals the square root of 10 squared, no, not 10 squared, that'll be 6 squared plus 10 squared. D is the square root of 136, which you guys told me was 2 radical 34. So notice the distance formula, okay, when we put numbers in, had the same calculations that we used here when we were doing Pythagoras. The distance formula has the same calculations, 9 minus 3, 11 minus 1, and then you squared it. Okay, you squared it here.
So, quick question.
Yeah.
So we're able to use the formula that you did on the left side, right? It's the same answer.
Pythagoras, if you want to use Pythagoras, yes.
So if you were to ask us a question on the exam to show our work, you wouldn't care which one we did.
That's correct.
Okay, thank you.
But I will tell you that there are, as you move into future math courses, there's time when this is much more efficient. Much more efficient. Okay. And they're going to look at you going, why are you using that when you could do this and be done with the problem? Or when they apply calculus to this, a first derivative of the distance formula, they're going to say this, you won't be able to use this at all. Okay. And that's 3 or 4 semesters from now. So don't panic. But right now, the two formulas give you the same answer, and I won't care. But you need to know that there's a formula out there, and it is more efficient the more difficult the problems get. But I don't care which one you use. I do want to show you something. Okay, is that okay for the distance formula, just in general for everybody? I'll have you doing a problem in a minute by your lonesomes.
When it says x2 minus x1 and y2 minus y1, are those interchangeable, or does it have to be a certain point on the graph?
They have to be the endpoints.
Okay, but it can be like either endpoint, right?
Yes, because what if, okay, that's a really cool question. Because what if you wrote 3 minus 9, okay, squared. Then you'd have -6 squared. But wait, -6 squared is still positive 36. So it doesn't matter whether you write 3 minus 9 or 9 minus 3. By the time you square it, it will become a positive number.
Okay.
Yes or no? Does that make sense? So it doesn't matter who comes first, x sub 2, x sub 1 in this formula. In other formulas like slope, that's where we've seen this formula before. We've seen, m equals y sub 2 minus y sub 1 and x sub, it matters there. But because this is being squared, it doesn't matter. Okay, I got a negative. Big deal. When I square it, it will become a positive. Okay. Does that answer your question? I know you said, yeah, okay. And
Yeah.
we kept talking.
Yeah, it's good. Thank you.
Okay. All right. Anybody else? Okay. I want to show you something back here at this formula. I'm going to erase all my work here and go to this distance formula for a second. Okay. In this formula, what can you do to get rid of the square root symbol? What math gets rid of a square root symbol?
Square both sides.
Yep, square both sides. So if we squared both sides, this would be d squared equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. So think about this for a second. By squaring both sides, we make it look not as nasty. And by the way, I found this formula much better when I was teaching calculus than this one. Even though the that's easy for you to say. Okay. Yeah, it looks less scary because that square root thing, whatever bothers people. But when I was teaching my high school kids calculus, even though this is the formula up here that you look it up in the book and that's what you get, this is much more efficient. Okay, but look at this. This is hypotenuse squared equals, this is leg squared plus leg squared. That's all that is. And this just says, how do you calculate the leg? You subtract the x's. How do you calculate the other leg? You subtract the y's. That's all this is saying. It's making a more formal use of Pythagoras. So the distance is really the hypotenuse, and this x2 minus x1 crud is really a leg squared, a leg squared. All right. But the question Lindsay was asking, and I know a couple other people were, well, does it matter whether you use Pythagoras to find the length or you use the distance formula? And for me, I don't care. So with that being said, okay, I want you to find the distance from point A, which is -7, -4, to point B, which is 11, 2. Find the distance from point A to point B. So let's see if I did it right or not. I'm going to first use the distance formula just because it's new and I want you to use to that. And then if somebody wants me to do Pythagoras, I'll do that one too. Okay, so the distance formula. Distance is big square root of second x minus first x. So that's 11 minus a -7. Notice it's minus a minus. The formula has a negative in it. So the first, this x minus this x. So this will become 18 squared plus, this will be 2 minus a minus 4 squared. So this is 18 squared plus 6 squared. Okay, so I got 360, the square root of 360. When you do 18 squared plus 6 squared, which becomes 6 radical 10. Whatever that is. Is that okay with everybody or not? Okay,
Yes.
anybody want me to do it on Pythagoras? Draw a triangle or not? Are you guys okay? As long as you got 6 radical 10, I'm cool. All right, I don't hear anybody saying that. Again, caution, the formula has a minus. So it's this number minus a negative, and you have to remember to pay attention to all those stupid little details. Okay, so in section 11.1, I need to erase the board here. We have the first two topics we talked about was the midpoint formula and the distance formula. Now I need to erase. Anybody gonna yell at me? No. So the next topic we're going to go to is a circle. Okay, let's look at my cone. Again, you don't need to write this down because my ability to draw is screwed. Okay, but if you take a cone like that and you take your lightsaber and slice it parallel to the base of the cone. I don't know how to, I don't have a cone in here. Where's Madonna when I need her? Oh, well. If you take a cone like this and slice it this way, and then take the two pieces and look at it, you'll have created a circle at the bottom of that cone. Okay, and that's what we're talking about. Now, I'm going to give you the equation, the full-on equation, and we'll talk about it. And you're going to get really scared. Don't. Okay. It's x minus h quantity squared plus y minus k quantity squared equals r squared. X minus h quantity squared plus y minus k quantity squared equals r squared. Okay, now we need to talk about this. The center of the circle is the numbers h, k. And I haven't done a whole lot of graphing theory with you. I've tried to do a little bit. Last chapter, we talked about shifting an exponential curve up or down. Remember how the k value moved it up and moved the asymptote up or moved it down? A little bit of graph theory. Well, the same thing here. This is going to take a circle, okay? And if you think of all circles as starting at the origin, like this, what this is going to do is it's going to move it over h units and up k units, okay? And we call those transformations, or we call those horizontal and vertical shifts. It's going to get shifted over h. Maybe we're going to go over h. We're going to go up k. And so we'll have the same circle, but it's been shifted over h, k. Those are shifts over h, up k. The radius is the r value. That number, r, whatever. So let's look at an example and have you guys kind of take it apart. Suppose I gave you x minus 3 squared plus y plus 2 squared equals, okay, I'll be a little bit tricky. Now, 9 equals 9. Okay. What's the radius of this circle? This is a circle. What's its radius?
3.
3. Okay. We know that because instead of 9, we can just say this is 3 squared. You can do that automatically. Some mathematicians get lazy. Instead of writing 3 squared, they just write 9. And they say, everybody can figure it out. Okay. So the radius is 3. Now, question, what's the center of this shape? And this is where we're going to get people into trouble. So the radius is 3, the center. Anybody want to take a shot?
-2, 3.
You're on the right track. Who said that? Lindsay?
Lindsay.
Okay, you're on the right track, but who always comes first on an ordered pair?
It's a -3, 2.
Okay, well, let's look at this. -2, 3, -3, 2. Anybody want to take another shot?
3, -2.
3, -2. Carmen said with very, I'm sure it's 3, -2. Anybody else?
You don't know me well. I always sound confused.
No, you sounded very sure of yourself then. Okay.
Pretty sure of her too
Is
now.
it the full equation?
And wait, I heard two things. What?
Like, is it x minus 3, like the full thing?
No. It's these numbers. The HK, the numbers, HK is the center shape. Okay, so it is these numbers. But only one of those is right. Okay, let me show you. And this is where math gets really nitpicky, and you guys kind of need to know this. Okay, the formula has its own minus sign, x minus h, but we just take the h number. Whatever that was, x minus h, so we take the h. Y minus k, so we take the k number. What's wrong with the y? It's not a minus. Okay, so you have to mentally see this is x minus 3 squared plus y minus a -2 squared equals, equals 3 squared. Again, let me move out of the way so you can see what I did. The x quantity was fine. It was great because it fit the form x minus a number. X minus a number. Great. But the y quantity was all screwed up. It didn't fit the form. Okay, the form says it's got to be y minus k. And we have y plus a number. So you have to use your knowledge from pre-algebra and turn this plus into a minus. And we already talked about how the radius was 3. So now the center of this shape is 3, -2. Okay, again, look at what I said over here. When it's x minus h, we simply take the h and say that's part of my center. When it was y minus k, we take the k and say that's part of my center. The hk becomes my center. Okay, and the radius is 3. Okay, how's that for everybody? Kind of okay? All right. And as usual, mom screws us up. So let's look at this. Let's think about this. Okay, what happened? Well, a circle with radius 3. You don't have to draw this yet. Just watch me and think. A circle with radius 3. 1, 2, 3. Okay, there. But what have we done to that circle? Okay, we've moved it over 3 units. We've taken the center, we moved it over 3 units and down 2 units. Okay, over 3, down 2. So we go over 3, down 2, and there is our new center. Does that kind of make sense? This would be a circle at the origin, at the center, but this is the same circle that's moved over 3, down 2. Now, I'm trying to get you ready for what mom is going to ask you to do. She's going to say, graph these. Okay, I'll show you how.
I have a question. What was
Yeah, go ahead.
What was the purpose of moving the origin?
That's what this problem says. This is a circle whose origin got moved. It got shifted over somehow.
But why did we do that?
Because it's math.
Yeah.
There's a purpose for it.
Okay, let's go back to when we graphed lines. That, why couldn't we have said that's the line y equals x? No, we made you say, what about y equals 2x? That's got a different slope. They're still lines, but they have 2 x's. What about y equals x minus 3? It's still a line. It's been shifted down 3. So we were asking you, okay, there's the basic line, y equals x. That's about as simple as you can get, okay? But we started moving it around, so you guys practiced with graphing it, okay? The answer, a less satisfactory answer, is graphs show us visually what we can't see here. Here's the equation. What's it mean? But when we see a graph in front of it, we can talk about its domain. We can talk about its range. We can ask, is it a function or is it not a function? We can do all kinds of things in picture format that we can't do in its equation format. And that's about the best I can say. Way back, we started studying equations, but then immediately we went to their graph, because sometimes it's easier to picture the problem in graphing form than it is in math form. That's about the best I can do for you, Mitch.
You're good.
Okay. I like Vince's question or answer better. Okay, because it's math. Shut up. Okay. That was implied, by the way. He didn't say that, but it was implied, right? Okay. Where is one more point on this circle? I know there's a circle here somewhere. I know there's a circle. Can you find one point on the circle? I can find 4 of them, but can you find one? Okay.
3, or sorry, 0, 3. No.
Well, okay.
3.
What would that be?
Wait. Yeah,
Radius.
0, -3, and that's where the circle touches the y-intercept.
Okay. Well, okay, you could do it. All right. You were better when you didn't know. Okay. I'm sorry.
3, 2.
No. How about 3, 1?
Mm-hmm.
You guys were all getting close. Okay. Why? Because the radius is 3. So if I said I'm at 3, -2, and if I'm at -2 and I go up 3, -2 plus 3 is 1. Okay. Now, what's that tells me? There's a lot of things that tells me. But what's mom going to do to you? Well, she's going to ask you to graph this. Okay. The first thing you're going to do is you're going to say, oh, this is a circle. She's going to give you all kinds of pictures. Is it a circle? Is it a straight line? Is it a parabola? Is it a hyperbola? Is it all kinds of things? Okay, which thing is it? So you're going to say, well, you dummy, it's a circle. So you're going to click the circle. And then you're going to click on the center. 3, the proper center, 3, -2. And then here's the fun part. You're going to use your mouse. It'll give you a little circle here, but you're going to use your mouse to expand this circle until it goes through that point. Then you're going to say, done, I submit it, I'm finished. So let me go back and tell you what we just said. Okay, your math says, I got to get 3, -2, radius is 3. Write that on your piece of paper somewhere. Mom says, okay, now graph the sucker. So you select, and you'll see a little menu. Okay, you say, this is a circle. So you click that. Then you go to your graph. Mom will give you a graph, and you click on 3, -2, the center. And poof, a circle will show up. You use your mouse to expand or contract that circle until it goes through that point. Okay, and then you click submit, and mom tells you you're wrong, and you go, damn it, and you go back and do it again, but we're right.
So for the 3, 1, can you explain how we would find that?
Well, yeah, I will. Okay.
Okay, thank you.
Okay. And actually, there's 4 points you could use. And as far as I can tell, I haven't seen mom reject me yet. Okay. We know the radius is 3, right? So if you're at the center and you go up the radius, okay, you're changing the y value. So -2 plus 3 more is +1. When you go straight up, the x value won't change, the y value will change. So that's how I found that point. Okay, and you just expand your circle on mom until it goes to that point. Now, just for fun, what if you wanted it to go through that point? What if you pick that point instead? What is that point?
6, 2,
Well,
-2.
6, -2. So again, depending on the size of your graph or whatever, you'd say, hey, mom, we're going to graph a circle. Then you click on the center. Then you expand or contract your circle with your mouse until it goes through that point. Or that point, it doesn't matter. Maybe this point doesn't fit. Maybe that point does. Maybe, it's off the graph, off the screen somehow. Cool, there it is. Okay, what if I wanted you to go through that point? Straight down. Where is that? Who is that?
3, -5.
Yep. Yes or no? And how about this point?
0, -3.
Nope.
0, -2.
-2.
That was the one I was attempting to say earlier, but it
Right. Well, I finally, when I got that point, I hadn't gotten there in my head yet. And I was just now realized I heard you say that almost. I mean, you were saying a couple other things, but you were pretty close. That's very good. Do you understand why when you move sideways, the -2 stays the -2? Only the x
Yes.
changes? Okay.
Yeah.
All right. So who was asking, how did I get these other points? Do you understand? Whoever, it doesn't matter to me. Do you understand how you got these 4 points? And as long as you expand your circle to go through one of those 4 points, mom will go, yeah, you got it. Is that all right with everybody or not?
Are there going to be any questions,
Yes.
Mom, where we solve without graphing?
What do you mean by solve? Some of her questions will say, here, what's the center and radius? And she'll just quit.
Okay, so she's not going to want us to find X and Y values for the circle without using a graph.
That's correct.
Okay, cool.
Yeah, just pretty much like I have here. You know, she always throws something stupid at you and you come back and yell at me or ask me or something like that. But between what she's going to ask and I'm going to give you a problem like this, say, what's the center, what's the radius, and can you sketch the graph? And she's doing essentially the same thing, except because she's a machine, you got to be a little bit more careful.
Okay.
Okay. All right. So let's see how you guys do. Okay. I want to try and trick you a little bit. So I want you to sketch this graph of x plus 2 squared plus y squared equals 36. X plus 2 quantity squared plus y squared equals 36. Now, I threw a trick at you. Do you guys want to work on it, or do you want me to walk you through it? You want to spend a couple seconds at least looking at it?
Spend a couple seconds.
Okay, we'll do that. I'll pause it. Okay. Couple things that are really weird about this problem that I wanted to make sure I showed you before some of you go out and start your homework on chapter 11.1. Okay. First off, what's wrong with x plus 2? What do you have to do, at least mentally?
Minus a negative.
Yeah, x minus a negative 2 quantity squared. Okay, because your h value is actually negative 2, because you got to make it look like this. Whoa, what's wrong with y squared?
It's positive.
Well,
Fell by itself.
got to have somebody with the y. It's got to always be y minus somebody.
Is the assumption is 1?
The assumption is,
Sure.
okay, question
0.
is, oh, there's a better assumption. Okay, y minus 0 squared. If you minus 1, that makes a change to the problem. Y minus 1 is different. Y minus 0 doesn't change. It looks different, but it doesn't actually change its value. Okay, you have to have a y minus something. If you put a 1 there, 1 is good when it's a multiplier. Then multiplying by 1 doesn't change it. But when you need to add or subtract, 0 is your number that doesn't change it. Okay, equals 6 squared. Okay, so there's a couple tricks I wanted to make sure you saw. We'll finish this off in a minute. So you had to take x plus 2 and change it to x minus a minus 2. That's number 1. When you have y squared, you have to see that there's an invisible minus 0 there, y minus 0 quantity squared. And 36 became 6 squared. So now, what's the center of this shape? It's a circle. What's its center?
Negative 2 and 0.
Negative 2 comma 0. What's its radius?
6.
Okay, so if we sketch this, getting ready for mom, go to negative 2, 0. Okay, now remember, mom wants you to select the circle, say, hey, mom, it's a circle. Yes. Then click on the center -2, 0. Okay, yes. And then get one of the corners, or that doesn't make sense on a circle, but one of the radii corners. So what if we went up? Where would it be if we went straight up? What would that point be?
-2, 6.
Yep, -2, 6. What if we went straight down? What if that was the point I wanted mom to go through instead?
-2, -6.
-2, -6. Okay, you guys all agree with Mitch?
Yeah.
Yeah, okay. What if I went out here somewhere? To the right,
4, 0.
4, 0. Okay, and wherever this is -8, 0. Now, I found all 4 of these. You don't have to find all 4. You just have to find any one of them. So you're going to expand your circle. Again, using your mouse, expand your circle. So it goes through one of these, whichever is easier for you to use on a particular problem. It might be on one problem, this is the easiest to go to the right. On a different problem, it might have been easier for you to find that point. All you have to do is find one of these, expand your circle so it goes through that point. That's all you got to do. That's it. You're happy. Now I want to show you one more thing. Okay. And then we're done for the night. And that's a shame.
How did we find the 4, 0?
I'm sorry?
How did we find the 4?
4, 0. Okay.
Yes.
Because, thank you for asking that, not letting me run you over. Where's my red pen? Because my radius is 6. So when I want to go over 6 units, I'm at -2 plus 6 is 4. -2, go over 6 is 4. When I go sideways, the y value doesn't change. It stayed 0. When I go sideways, the x value changes. Is that okay?
Yes.
Okay. Same way here, I went 6 this way. -2 goes 6 backwards is -8. That's how I got that -8. Okay. Are we okay with that or not, everybody? All right.
Yes.
So that's mom. Now, still on circles. I don't know where to begin this one. This is nasty. Okay. This is, if you guys are going to really balk at this next one, okay, and I'm going to keep showing you over and over. But what if I said, what if I gave you this problem? X squared plus y squared minus 6x plus 8y minus 11 equals 0. X squared plus y squared minus 6x plus 8y minus 11 equals 0. And what if I said, okay, this is a circle. Later, I'll tell you how to recognize it's a circle, but this is a circle. What's the center? What's the radius? What's the domain? What's the range? Okay. Well, I'm going to show you how to do that. We're going to use a process called complete the square. Which was taught briefly in chapter 9. Okay, but I think I gave you like one or two problems, maybe 4 problems, whatever. Complete the square. CTS is what I call it. And you're going to have to know this. I've loaded the chapter 11 test with several problems where you must know this process. Okay, so here we go. So what we do is we get the x's with the x's. Okay, so look what I did. I rearranged the problem. So I got x's with the x's, y's with the y's. I moved the 11 to the other side, just got it out of the way. And I left room for the magic number. Now, again, we talked about this in chapter 9, but that was such a long time ago, I'm sure you guys forgot. So that's the first step. Second step is, how do I get my magic number? Well, it was always half times -6, okay, is -3, but then we square it, which is 9. Okay. Over here, half times 8 equals 4, but we square it. Now, I'm hoping some of you maybe remember finding this magic number. It's half of the x value, or the b value. Half of the b squared is the magic number that needs. Half of the 8 is 4 squared. But if you stop here, okay, you're really wrong, because you've just violated a fundamental rule of algebra. And that is, I've added 9 to the left side and 16 to the left side. So I just added like 25 to the left side. I've made my problem really unbalanced. So to keep it balanced, I have to add 9 and 16 to this side also. I got the 9 because I did -3 squared is 9, positive 9. And I got the 16 because 4 squared is 16. So I have to always, whatever I put here, I have to put on the other side. Now, the other thing I said is, if you did this right, this will automatically factor into x minus 3 squared. Whatever that number is, it'll factor that, x minus 3 squared. Plus, this will factor into y plus 4. That number squared. Okay, and this will become 36. So what's the center of this shape?
-3 and -4.
Nope.
+3, -4?
Yep. +3, -4. Take, if it's a minus, you take it just as it is.
Gotcha.
If it's a plus, you take its opposite. That's what most students do. Most students don't bother to go with that minus and minus crap. They just say, if it's a minus, I live with it. If it's a plus, I take its opposite. The radius is 36. I'm not going to bother to graph it. I don't want to do that.
Isn't the radius 6?
Yes. Thank you. 6. Okay. All right. We'll do 1 or 2 more of these tomorrow night. We'll get into some other stuff. I don't know if I want to get into parabolas or ellipses tomorrow night. Ellipses are easier, but whatever. So that's it. See you tomorrow night. Come loaded with questions. Chapters 9 and 10. Hasta bye-bye, guys. See you later.
Thank you.
Are you gonna be answering questions tonight?